Welcome to Chapter 4. We'll explore how our bodies are highly organized and even more so, highly regulated. So even though it may not seem like you're any good at multitasking, or maybe you think you are, as you have music and a movie and Facebook and whatever else streaming on your screen or around you, your body is really great at multitasking. So even without you having to think about it, you are digesting food, growing hair, circulating blood, making saliva, breathing, blinking, walking, and talking all at the same time, right? So tissues are composed of specialized cells of the same type that perform a common function in the body. So the tissues of the body can be organized into four major groups. So first up are connective tissues, and these will support, protect, and bind other tissues together. They include your bones, tendons, and fat, and other soft padding tissues. Next are the muscular tissue. There are three flavors, but overall, they help to cause movement in your body. Like they help you to raise the roof or allow food to go from your mouth to your butt, or they will allow your heart to beat. Next, we have nervous tissue. And nervous tissue is found in your brain and spinal cord and nerves. And this is all about internal communication so that your brain can kind of oversee and be informed of everything that's happening in your body. Finally, we have epithelial tissue. So epithelial tissue is an interesting one, and it has a lot of different jobs. It will line the walls of your digestive tract organs, as well as your blood vessels, but it's also found on the outside of your body, like on the surface of your skin. So it helps to form boundaries between different environments. It will protect, secrete, absorb, and filter. We'll look first at connective tissues. So connective tissues bind body parts together, and although they're really diverse in structure and function, connective tissues all contain specialized cells, ground substance, and protein fibers. So the word matrix includes the ground substance and the fibers. So there are three major types of fibers. We have collagen fibers. The collagen fibers are shown here in pink. These are unbranched, strong, and flexible fibers. Also have reticular fibers. So they're shown down here. These are branched and thin, and they form a network, kind of a suspension or webbing in which everything else gets to be supported. And then finally, elastic fibers. And these have kind of the consistency of a rubber band. So they allow for some stretch, but also recoil. And this particular example is kind of loose connective tissue. And this, for example, if you were to pinch the skin on the forearm, you might notice there's like skin and a little bit of fat. And then below, though, it's this layer that helps to anchor the skin to the muscles that are below. If you've ever dressed an animal, not like dressed it up in a costume, but if you've been out hunting, or maybe you've done other laboratory dissections in your life, this has about the consistency of like cotton candy as you peel it away. It's like your body's packing material. So the first of three general classes of connective tissue is called fibrous connective tissue. And this is made up of cells that are called fibroblasts. Okay? So some examples here. And we can utilize kind of our knee, what's inside of our knees, to kind of see these different classes of connective tissues. So the first example, the loose connective tissue is adipose tissue. And adipose tissue is simply fat tissue. And you see that here shown in the yellow. So again, if this is your knee, this is your femur bone. Then down here is your tibia. And then the muscles here of your calves. Here's your patella, right? So there's a lot of soft padding, cushioning tissue there in the adipose tissue. And we also have dense fibrous connective tissue. Now, this is like rope-like tissue that's found in tendons and ligaments. So this, for example, is a tendon that will come from the merging of your quadriceps muscles. And it will come down here and then attach onto your tibia, front side of your shin bone. Now, this image up here, the loose fibrous tissue, is what we saw in the cartoon in the slide prior. We also have supportive connective tissues, and this is made up of cartilage and bone. So we have cartilage here. This is hyaline cartilage, for example, but there are other types, elastic and fibrocartilage. But in our example of the knee, you'll have this slippery, smooth hyaline cartilage that caps the tips of your bones that are inside of the joint cavity. So it allows for smooth, frictionless movement as you bend and straighten your knee. And then the matrix for bone, and this is bone, kind of looks like tree rings when you look at it in histology. The matrix here is solid and rigid. So there, are two examples. You have compact bone, and compact bone is the sturdy, tough, thick bone that's on the outside of your bones, where spongy bone is kind of like, right, you guessed it, a sponge. So it's lighter, it has some holes, it allows for blood vessels and fat and nerve to pass through. But in its lightness too, it makes you more movable. Otherwise, it might be too heavy to move your body around. The last type of connective tissue is a fluid connective tissue. This is an interesting kind of variation on connective tissues that includes blood, which we see here, and lymph. So blood includes red blood cells, erythrocytes, which are for transporting oxygen. Those have white blood cells, which are called leukocytes, and those are for mounting immune responses. And then finally, platelets. And platelets are these little chunks of cells that help to seal small or big tears in your injured blood vessels. So if you have like an avocado slicing accident and you do cut open the palm of your hand, platelets will be hard at work to kind of avoid bleeding too much. Now the yellow in the background is the interstitial fluid. This is also called plasma, and it's the fluid in which all of these other cells are suspended. For your review, little flow chart of the different types of connective tissue, fibrous, supportive, and fluid, and some of the examples of what you find under each heading. Now on to muscular tissue. Its main job is to move your body. So there are three types. First, we'll look at skeletal muscle. So skeletal muscle is the muscle that's attached to your skeleton. And this is probably what you work out when you go to the gym. So if you go to pump iron and you're doing your lat pull downs or leg presses or super squats, I don't know, you're contracting these skeletal muscles. Now, skeletal muscles are interesting in that their cells are shaped like a spaghetti noodle. So the cells themselves are long and cylindrical, again, like a spaghetti noodle. So some of these cells can be like 2 or 3 feet long. Now, this is an individual cell, but if we were to take a a slice of muscle and stain it, we would have some histology. So in histology, you can look for some identifying factors that help to distinguish, like, oh, this is skeletal muscle versus some other type of muscle. So it has striations, and striations are just stripes. So you can see these little stripes or striations here, right, along the cell. Now, these all are voluntary voluntarily controlled. So you can decide when you want to raise the roof or give somebody a high five or whatever else, right? There are reflexes involved to help maintain your posture, but overall, you can control how your skeletal muscles contract. Now, the next are smooth muscles. These are spindle-shaped. They do not have any striations, and you find them in the walls of your hollow organs, like your blood vessels and your digestive system. These are involuntary, so you don't really control, you don't have to tell your stomach, hey, squeeze my lunch into the duodenum, right? It's going to do it kind of on its own or with the direction of your central nervous system. Finally, cardiac muscle is found in the walls of your heart. Its main job is to pump blood through your body. It has striations, but also a branching arrangement in the cells themselves. So it's not as nicely organized as skeletal muscle tissue. This too, right, is involuntary. So thankfully, you don't need to tell your heart when to beat and how. Nervous tissue is made up of neurons and different types of supporting cells called neuroglia. Nervous tissue is found largely in the brain, spinal cord, and nerves. And each neuron, this is a neuron, and this is a neuron. Hey, one is a cartoon and one is histology. I'm sure you can tell the difference, hey? But each neuron has different parts. So we have this cell body, which it kind of looks like a balloon or like a kite, right? And the cell body, it contains the nucleus, which is where all the information gets processed. And we have this area, the input region. So the input region is the dendrites. So extending off of the cell body over here, these are the dendrites. So what'll happen is some information comes to the dendrite and then it gets processed here in the cell body. So the information could be something like, oh, we just put our hand on a really hot burner. It gets processed here by the cell body, and then an outgoing message goes down the length of the axon into the axon terminal. So this is the end of the road. And likely it's attached to some skeletal muscle, right? Here's our striations, whatever. Looks like a loaf of bread, really. But if you had put your hand on a hot burner, this would activate the muscles of your hand and forearm to move your arm away from that heat, right? So you don't burn yourself. Right? Now the supporting cells are called neuroglia. They come in different flavors like astrocytes or oligodendrocytes or these little microglia. Okay? Epithelial tissue covers the body and lines its cavities. Right? So covering and lining membranes. There are three types of cell shapes. We have the classic squamous, which looks like a fried egg. It's thin and small. Cuboidal, which looks like a cube. And then columnar, shaped like a column. So these are the major cell shapes. They can also be divided into further classes. So you can have simple, which is just one cell thick, and usually these epithelium are arranged in sheets, right? You can have pseudo-stratified, and pseudo means a fake or false. Stratified means layered. So these are columnar cells that might have some smaller cells at the bottom. And then finally, stratified cells. So these are cells stacked one upon the other to help protect more from abrasive environments. Okay? So stratified epithelia will often have a basement membrane, or all epithelia really, a basement membrane upon which it's attached, and then what's called an apical layer. So the outer facing or the inward facing layer. And this will make more sense in a sec. Okay? So epithelia can also be structured as a gland, and a gland will produce some type of product, like you have salivary glands that produce saliva, you have sweat glands that produce sweat, or mammary glands that produce milk, okay? And they can either release their products into a duct or straight into the blood. And if it's into the blood, it's called an endocrine gland. We'll talk more about those later on. So here are some examples. We have simple squamous epithelium, right? And most of these epithelia will have a first, middle, and last name. So this is a thin sheet of smaller cells that allows for a really efficient absorption and diffusion of oxygen in, carbon dioxide out, still while maintaining some protective mechanisms. In the next image, we have what's called simple cuboidal, and this arrangement is slightly different. So here, the cuboidal cells are making like a tube, or if you look at them in histology from the top, it's like you're looking at the top of a straw downward. And so here are the cuboidal cells. So they're a little thicker, and they allow to withstand a bit more abrasion than the fragile simple squamous. These you'll find in the tubules of your kidneys and other glands, like your salivary glands. And finally, on this page, we have simple columnar cells. So these columnar cells are found largely in your small intestines, and their main job is to absorb nutrients. So if you eat, right, your favorite breakfast of a Pop-Tart, in a few hours, the Pop-Tart will be broken down into its micromolecules or monomers, which should then easily be absorbed into your bloodstream, right? Kind of in that mechanism. Now, these cells are really tall, and that helps to withstand some of the abrasive stuff that happens in your small intestines. As you might not always be eating like soft Pop-Tarts or applesauce. Every now and then you might have, some corn or a taco shell or some Doritos that usually get broken down and softened by the time they reach this area, but maybe not. Here in the trachea is your windpipe, we have the pseudostratified columnar epithelium that contains cilia. So the cilia are those little cellular projections, right? Man, I got a haircut the other day and it looks so silly. I know, it's dumb. Okay. But the cilia helps to catch and filter debris. So it will kind of sweep that debris kind of back toward your throat, so you just swallow it. Now, people who smoke, and this could be smoking anything, the cilia gets degraded. So it no longer has that job of sweeping debris toward the throat, which is why smokers will often cough more than non-smokers. So they have to cough to propel that stuff up and out. Finally, stratified squamous epithelium. Now, one basic example here is in your skin. It's made up of stratified squamous epithelium. So this basement membrane is kind of anchored to that areolar connective tissue below, like way below. This basement membrane is anchored to your dermis, but the dermis below is then anchored to the areolar connective tissue. And these cells will help you avoid like paper cuts or, having the underlying structures exposed to the outside world. Now you also find this in places like the lining of your nose, your mouth, your esophagus, the anal canal, and the vagina. Same type of structure, same type of cells make up all of those different body parts. Now we get to look at our first body system. So if you remember back, organs are made up of two or more tissues that work together to perform a common function. Now an organ system involves several organs that all cooperate together. Now, skin and its accessory organs make up the integumentary system, right? So this helps to protect your body, provides temperature regulation, also helps to make vitamin D, and receives sensory input. So this all includes your hair, skin, your nails, and some of your glands. So here's a slice of your skin. Now it contains 3 major layers. So the outermost layer, let's do a little drawing here. The outermost layer is made up of stratified squamous epithelium, right? So all of this. And this will get, if you've ever exfoliated your skin, you're kind of like sloughing off. This is the top layer there. Right? Now the middle layer is called the dermis, and this is the leather of your skin. This is by far the busiest area in your skin, as it contains things like a hair follicle, different little sensory nerve endings. It will contain some oil glands. This is an oil gland that produces sebum, and that sebum will leave out through the same route as your hair follicle. And if you make too much sebum, it can cause acne. And then down here you also have what's called an eccrine or sweat gland, and that will just produce like waters and salts, and then that leaves out to the surface of the skin to help cool you off. Kind of looks like a coiled up snake, right? You'll also have blood vessels. So you have some arteries and veins down here, which is why when you slice yourself open when you're cutting up an avocado, that's why you bleed. There's blood vessels just underneath your skin. Then the subcutaneous layer, or the hypodermis, is the layer below. This will contain some fat and connective tissue. Other accessory organs include your nails, like your finger and toenails, the hair follicles I just mentioned, the oil glands, and the sweat glands. One last thing, and this you don't need to know, but it's kind of cool to see. This structure right here is called the erector pili muscle. So when it contracts, it will tug on your hair follicle down here and make your hair stand on edge. And that's what gives you goosebumps, right? It's super cool. Now, organ systems. We just talked about the integumentary system, and I'll ask that you kind of review each of these body systems, but I imagine you'll kind of intuitively know what each of them kind of essentially do. Like the cardiovascular system helps to move nutrients and waste around your body. Lymphatic system provides protection against infections and disease. Your digestive system is all about taking in food, breaking it down, and then using those food components for your body's activities. Respiratory system, exchanging oxygen and carbon dioxide. The urinary system produces urine, and in that urine filtration process, helps to get rid of any metabolic waste products in the body. The skeletal system, so your bones provide support and protection. Your muscular system allows for movement. Your nervous system is that command and control center of the body. Endocrine system produces hormones that is kind of like the second-hand man to the nervous system. So it's second in control. And then the reproductive system. So this produces eggs and sperm, and then will, in the females, help to facilitate offspring development, right? Okay. So on to organ systems, body cavities, and body membranes. Or onto body cavities and membranes, rather. So your body cavities, and these are spaces inside of your body, so it's not just like everything is like sliding around all willy-nilly. They're lined by membranes, and these can be mucous membranes. Mucous membranes you have like in your nasal cavity, around your eyes, in your respiratory system. Serous membranes, like your heart is inside of a little sac that's filled with serous fluid. You also have synovial membranes, and these are kind of the spaces within your joints, okay? And then the meninges. Meninges are protective coverings around the brain and spinal cord. So in terms of cavities, there are two major cavities in the body. Let's do a little bit of this, okay? So on the back side of the body is the dorsal body cavity. You can think of it like dorsal, like a dorsal fin, okay? It contains the cranial cavity and the vertebral cavity. And I'm sure you can piece together what's housed in each of those areas. Now, the ventral body cavity on the front side of the body, let's take a peek down here, contains three particular regions. So the first is the thoracic cavity. This is found in the thorax or your chest. This is where your esophagus, your heart, and your lungs hang out. Now, there's this big muscle called the diaphragm, and it sits like an opened up umbrella and helps separate the thoracic from the abdominal cavities. So the abdominal cavities abdominal cavity contains all of your digestive organs, right? Your stomach and your spleen and your small and large intestines. Now the pelvic cavity, and this is usually separated, but there isn't a real barrier here. We just describe it differently. It contains the reproductive organs. So say in females, like the uterus and the ovaries, as well as the urinary bladder and the rectum. Homeostasis. Homeostasis is the relative consistency of the internal environment in your body. So all of your organ systems contribute to maintaining homeostasis. This is like coloring inside of the lines or driving in your own lane. So for example, the cardiovascular, respiratory, digestive, and urinary systems will directly regulate important things like the amount of gases, nutrients, and wastes in the blood, all while keeping your interstitial fluid levels constant. Okay? Now the lymphatic system will absorb extra interstitial fluid and helps to function in immunity so you don't get sick. Now the nervous and endocrine systems will regulate everything else. So this next image in your text kind of gives an overview of each of the systems that we'll explore through the course of the semester and how they contribute to maintaining homeostasis. So I'll highlight just a couple. So for example, the cardiovascular system. This will transport oxygen and nutrients to your tissues and then transports wastes away from the cells. It'll also transport hormones throughout your bloodstream. So if your cardiovascular system, like your heart, isn't able to pump and move oxygenated blood through your body, you will likely die, right? You need the pump to be working in order to maintain homeostasis. Let's see, another one here, the respiratory system. So this supplies the blood with oxygen that's needed by the tissues, right, the cells of your body, and rids the blood of carbon dioxide. So this all helps to regulate the acid-base balance of the blood. So two, if your airway is cut off and let's say oxygen can't come into your system, but your heart is beating just fine, it's not going to be able to beat that oxygen-rich blood to your body because it's not coming in. And then two, right, death can happen. So I'll let you kind of peruse each of the different systems, digestive, muscular, and so on, and see how they contribute. Now here's our little seesaw. We saw this a while ago. Now homeostasis is regulated by two major systems, negative feedback and positive feedback. And negative feedback isn't like, oh, you're doing a bad job, you need to do better. And positive feedback isn't like singing your praises. They all have to do with what they're doing with the initial stimulus that's received. So when a sensor will detect any change in kind of normal ranges, it's going to kind of reverse the initial stimulus. Okay? So we look at an example in terms of body temperature regulation in a sec. But negative feedback is the most commonly used feedback mechanism, and it's used to regulate your blood glucose levels and regulate your body temperature. And your book has a nice example, kind of comparing this to using a thermostat and a furnace in regulating room temperature. All right, so let's check out this example. Say you get too hot. So here's our normal body temperature, about 98.6 degrees. Say we get above temperature because we are like hanging out in the heat of Arizona and we're running an ultra marathon, right? That's our stimulus. It's going to kind of spark our sensors. And I don't like this picture of a brain as a sensor. You might more so think about, let's see if I can draw a person. This is really awful. Okay, this person is sweating. So here's some beads of sweat dripping down. But the skin receptors will kind of pick up on the extra heat. And that's going to send the information to the control center. Now the control center is your brain. There's an area of your brain called the hypothalamus that likes to keep your body temperature at about this 98.6 degrees. If you're getting too hot, it's going to send some effector message, usually to your blood vessels and to your sweat glands. So when your blood vessels dilate, this might make you kind of pink or red in color, and that will cause like extra sweat to be released. So when you sweat, there we are, body temperature goes back to normal, right? So in a negative feedback mechanism, what will happen is you will essentially reverse the initial stimulus. So you get too hot, you want to get colder, right? So this same thing can happen on the flip side. Say you're below normal body temperature, okay? The stimulus is the cold weather. You're outside in your Alaskan winter in the cold without a coat on. And again here, the sensor maybe is like your skin. Don't think about your brain. Your skin will send this information to your brain to say, hey, we're cold now. And this outgoing message or effect will be to tell your blood vessels to constrict, so you're not sending so much blood to different, like the faraway parts of your body. But you might spark shivering. So if shivering happens, that's the contraction of your skeletal muscles, and it's designed to warm you up, right? Right. Now, positive feedback mechanism happens differently. So in a positive feedback mechanism, this is going to bring about a rapid change in the same direction as the stimulus, and we're not going after stability here, right? So it's almost like if this dog up here, we're trying to catapult the other dog, like let's get this dog really high. That's a positive feedback mechanism. Okay? So one example here is during childbirth. So say a woman has been harboring a spawn here for a good 40 weeks, and there comes a point when the head of the baby is pushing up against the cervix. And the cervix is this little bridge between the uterus or womb, where baby is hanging out, and the birth canal or the vagina. So what will happen is the head of the baby pushes up against the cervix, and that's going to send a nerve impulse to the brain. The brain is going to say, oh, we need to release this hormone, oxytocin. So oxytocin is a hormone, meaning it's going to travel through the blood back to the uterus. Okay? Now, this is going to cause the uterus to contract. This is a uterus contracting, by the way. Okay? Contract forcefully. And what is that going to do? That's going to cause the head of the baby to press more so up against the cervix, which is going to cause more nerve impulses to be transmitted to the brain, more oxytocin in the blood, stronger uterine contractions, right? So it will up level the forcefulness of the uterine contractions. That's positive feedback. So by no means would you want a negative feedback mechanism. Otherwise, little baby is just going to be stuck in there, right? Now, one quick example, and it's pretty silly. Say, for example, your favorite guilty pleasure is like listening to Justin Bieber. Me? Not my personal favorite. Or is it? Me? Say, for example, though, I'm sitting in traffic with my windows down and I've got my Justin Bieber on low, but I hear the guy next to me is also like blasting Justin Bieber, right? This is going to spark a positive feedback mechanism. So I feel comfortable, I turn up my Justin Bieber, he maybe turns up his Justin Bieber, and here we are having a little car dance party before the light turns green, right? Positive feedback. Now, negative feedback may be I'm sitting at that same stoplight, I've got my Justin Bieber on, and I look over and I see like, oh, one of my students. And I'm horribly embarrassed, like to admit that I actually like Justin Bieber. So I don't really, or do I? So I begin to roll up my window so nobody can hear what I'm listening to, and I turn down my Justin Bieber. That's a negative feedback mechanism. Makes sense, right? Right. That's it for chapter 4. Have a lovely week.